Today, in this lecture, we are going to see what are all different types of problems available in Gauss-Seidel load flow solution. First of all, we will recap what are the different problems available. First thing is, if they had given a PQ bus, we know P and Q will be known. We need to find the voltage and voltage angle 10. So, by using this formula, we will be finding the voltage. And after finding the voltage, if you convert that voltage into polar form, you will be getting magnitude of voltage and angle 10. Second thing, suppose they had given PV bus. If they had given PV bus, first thing is we had two different models in PV bus. Given a PV bus without a range of Q. Without giving any range of Q, they had given directly a PV bus. Then what you should do? First of all, you need to find the Q using this formula. In this formula, you can use the voltage they had given, VI, magnitude of VI, considering the angle as 0, and substitute this QI and find the value of VI again. Now, you will get a real part and an imaginary part. Let the real part be EI calculated and the imaginary part be FI. Now, to find the FI, imaginary part of the calculated voltage will be same, whereas the real part should be changed. So the final real part EI final is equal to square root of given PV bus voltage whole square minus the imaginary part whole square, which will give you the real part, final real part plus J imaginary part obtained here. This is one type of problem. Suppose they had given you a problem with some range. They had given you Q is in between like 0.1 less than Q less than 0.2. That is, they had given Q a minimum and maximum values of Q. Power mismatch range they had given. Now what you should do? First step is by considering this voltage, you substitute this voltage in this formula, find the value of QI. Now check the QI is within the range or not. If QI is within the range of Q minimum and Q maximum, then you proceed as the previous problem. That is finding PI by substituting that QI and then again finding the real part, holding the imaginary part as it is. Suppose if this Q is not in the range they had given, if the Q obtained in this problem is not in the range of what they had given, then what to do? Suppose they had given the range of 0.1 less than Q less than 0.2. You got 0.1, suppose 0.09. If you see 0.09 is less than Q minimum, that is 0.1, then you should fix QI as 0.09. Suppose if you had got 0.3, 0.3 is greater than 0.2, that is Q maximum, then you should fix Q as 0.3. So, when the Q you obtained is not in the range of Q minimum and Q maximum, if it is near to the Q minimum, make QI as the Q minimum. They had given range. If it is near to Q maximum, make it as Q maximum. After fixing Q, you already know the value of P. Now you consider this problem as a PQ bus and start doing. So, PV bus or a generator bus, after finding Q, if the Q values lies within the range, then you will proceed as a PV bus. That is finding the voltage and finding the real part of voltage, keeping the imaginary part as it is. If the Q is not in the range, if Q is near to Q minimum, fix Q as Q minimum, or Q is near to Q maximum, fix Q as Q maximum. Then fixing that Q and taking the given P and neglecting this voltage and proceed as a PQ bus. When you are proceeding as a PQ bus, remember you should not take this VI. Why? Because this voltage is for PV bus. PQ bus, only P and Q will be known. P is given, Q you are fixing either minimum or maximum. So voltage should be taken as flat start, not the given voltage, and proceed as a PQ bus. Now you will understand clear after seeing some problems. First problem, the magnitude of voltage at bus 1 is 1.05 per unit. They had given 1.05 and angle V and del given. So this is a slack bus. Then The scheduled loads at bus 2 and bus 3 are marked in the diagram. Megawatt is a unit of real power. Megavolt ampere is a unit of Q. So PQ are given. So second is a PQ bus or load bus. Here third also they had given P and Q. So third one is also a PQ bus or load bus. Now line impedances are marked in per unit of 100 megavolt ampere. Base value they had given. Now we should do the Gauss-Seidel method. Find the voltage V2 del 2, V3 del 3. Since PQ buses, 2 and 3 are PQ buses, we should find the V2 del 2, V3 del 3, and the slack bus power, line flows, and line losses. First of all, this is the given single line diagram with impedances. Now we need the admittances. So I am finding Y12 is equal to 1 by Z12. That is 1 by 0.02 plus J0.4, which give you 10 minus J20, which is Y12. Similarly, Y13 and Y23 also I had calculated, and I draw the single line diagram with admittances. Now they had given S2, that is power. You can see this is the S2. S2 is equals to P plus JQ. This is actually the actual values. Now we need to convert them into per unit values by dividing with base. In question, they have mentioned the base of 100 MVA. So I am dividing 256. One more important thing is, whenever you are finding the scheduled power, yes, for a PQ bus or load bus, take negative. Whenever you are finding a scheduled power of PV bus or generator bus, take positive. Since here second bus is a PQ bus, the scheduled power will be negative of actual value divided by base value. That give me the per unit. Similarly, third bus is also PQ bus in this sum. Negative of actual by base give me the per unit value. Now, since 2 and 3 are PQ buses, I am taking the voltage as flat start voltage 1 plus J0. Now, I am finding V2 of 1, which is P2 minus JQ2. P2 is this one. Minus JQ2 is minus 1.102. So minus of minus becomes plus by V2 conjugate. You can apply this. You can apply this formula. If you apply this formula, you will be getting that. Then Y12 V1, Y23 V3 of 0 by Y12 plus Y23. I am finding V2 of 1. You can see here Y22 is not there. Actually, the formula is, since here it is I is 2, Y2j, summation j is equals to 1 to 3, j not equal to 2, Y2j Vj. So Y21 V1, Y23 V3. And j is not equal to 2. So Y22 V2 won't come. Divided by the same thing. Y22. Y22 means Y12 plus, that is Y21 plus Y23. This will give you V2 of 1. Now, similarly, I will find V3 of 1. Using the third P3 schedule minus, using this formula, you can find V3 of 1. Now, after finding voltages, now you got here a complex form, A plus JB form. You convert this into polar form, you will get voltage at an angle of del. That is V2 and del 2 you will get. Similarly, if you convert this into polar form, you will get V3 and del 3. Now we need to calculate slack bus power, line flows, and line losses. Slack bus power. Slack bus power means this is the slack bus power. That is first bus. You know, first bus is a slack bus. Slack bus had only voltage as well as del. We need to find P and Q. Second one, third one are load buses. P, Q given. We found out V and del. First bus is a slack bus. So they had given P, V and del. We need to find out P and Q. From the formula, you can, in this formula, you can keep this alone one side and take remaining other side. You will get this formula. Substitute everything. One important thing is, while calculating V2 of 1, we will be taking V3 of 0 and V1. What is V1? V1 is 1.05. After calculating V2, during the calculation of V3, we will be taking V2 of 1. That is the recent value what you had got. Note this is a very important point. In the calculation of V2, since we don't know V3 of 0, we will be taking it as flat start voltage. V1 is a slack bus, so given voltage will be taken. In the calculation of V3, V1 is always fixed slack bus. V2, we won't take flat start as we had already calculated the V2, the calculated value only taken. Now, you will keep calculating this from this formula. You can calculate, and the real part will be is equals to P, imaginary part will be is equals to Q. Since they are in per unit, we know base is 100 MVA, you multiply with 100 to get the actual powers at this slack bus. Now, we had computed this slack bus power. Now, we will see how to calculate line currents. We know I is equal to V into Y. Now, I12 is V1 minus V2 into Y12. I21 is minus of I12. Similarly, I13 is V1 minus V3 into Y13. I31 will be negative of that. I23 will be V2 minus V3 into Y23. I32 will be negative of that. Finally, line flows. We know S is equal to V into I complex. So S12 will be V1 into I12 complex conjugate. S21 will be V2 into I21 conjugate. S13 will be V1 into I13 conjugate, and S31 will be V1 into I31 conjugate. Similarly, you can find all the things. Then line losses. Line losses SL12 is equal to S12 plus S21. I had derived all these things. I had explained the derivation in the previous video. Then SL13 is equals to S13 plus S31. SL23 is equals to S23 plus S32. With this, here actually I am calculating per unit values and multiplying with 100 to get the actual value. After calculating the voltages, voltage angle, power, real power, reactive power at different buses, and line currents, as well as line flows and the line losses, we need to draw power flow diagram, which is very, very important. This is the slack bus. At slack bus, we had calculated P and Q, right? See, P is 409.5, Q is 189. You should represent that here. At slack bus, 409.5 is P. Representation of P is this. Representation of Q is this arrow mark with a cut. So this is P and this is Q. Similarly, at I12, we had calculated. At I12, we had 1.9 minus J0.8. And then losses, when we come to losses, S12, 199.5 plus J84. That only we had written. See, 199.5 is the real power loss. 84 is the reactive power loss. Similarly, at 2, S21, we will see at S21, minus 199 and minus 67. So, minus 199 means in this direction. So, taking opposite direction, plus 199 and plus 67. Always, the standard is from the bus away. Away is taken as positive. Since we got minus 199, we will be taking towards the bus. Similarly, you can fill all the things in this diagram. This is the power flow diagram. Now, this is the first model problem. That is PQ bus problem. Now, let us move on to PV bus problem. In this problem, they had given the magnitude of voltage at bus 1 is 1.05 and the angle. So, this is a slack bus again. And bus 3 is fixed at 1.04 with the real power. They had given V, magnitude of V and P. So, this is a PV bus. A load consisting of 400 megawatt and 250 megavolt ampere. They had given PQ at here. So, 2 is a PQ bus. Line impedances are marked on per unit of 100 MVA. Then, now we will see here they had not given any power mismatch range for Q. This is the second type of problem. First of all, we will be finding all the things Y12, Y13, Y23 and the scheduled power as I said in the previous case. Scheduled power is, since at 2 is a load PQ bus minus of 400 plus J250 divided by base 100. Now, S3 we cannot find out. Why? Because S33 is a PV bus where we don't know the value of Q. So, P3 is equal to plus of, as I said, For PQ bus, it is minus of. For PV bus, it is plus of. P3 is equals to plus 200 divided by 100. That's what we had written here. Now, since V2 is a PQ bus, assuming flat start voltage, and the V3 is a PV bus, they had given 1.04. I am finding the voltage at the second bus. Now I got V2. After getting V2, if I convert this into polar form, I will be getting V2 and del 2. So second bus part is completed. Coming to third bus, since there is no power mismatch range, first I will be finding the value of Q3 using this formula. In this formula, as I said in the previous problem, wherever V2 is there, you should take the previous value, not the flat start voltage. After finding the Q3, now, as I said, we need to find V3, substituting this Q3. See, we are finding V3, substituting this Q3. Now we got this V3 as 1.0378 minus J 0.00517. This imaginary part is correct only, but the real part we need to calculate again. So finding the real part, 1.04 is the given voltage. The problem itself, they had given 1.04. So 1.04 whole square minus imaginary part whole square. That will give my real part. This is the final real part and this is the imaginary part. Now this is till here we had calculated second bus voltage and voltage angle, third bus voltage. This is the final voltage. Now if you convert this voltage into equivalent polar form, you will be getting del 3 and we had calculated Q3. Q3 del 3 are calculated. Now coming to the line currents as usual, I12 can be written as Y12 into V1 minus V2. I21 is the negative of I12 and I13 can be written as Y13 into V1 minus V3. This remains same, line currents, line flows, that is V into I conjugate, and line losses. Line losses is, yes, it is sum. Coming to the final problem, final model problem. See here we had 4 buses. This is a 4-bus system. Now they had given, instead of giving in the diagram itself, they had given differently. In the previous problems, if you had noticed, they had given the impedances and the power and the voltage in the diagram itself. But in this problem, they had given in a tabular form. See, for bus code na bus number 1, there is no P and there is no Q. Only V and the angle del given. So it is a slack bus. Bus number 2, P is given as 0.5 and voltage is given 1.04 and Q range is given. Whenever I said PV bus, they can give without Q range. You should proceed in the previous problem. You should proceed like previous problem. Here they had given PV bus with Q2 range. Okay, let us see how to solve this. Now they had given P, they had given Q. So third bus is a PQ bus. Fourth bus is also a PQ bus. So third and fourth buses, I won't explain you again how to do. Since they are PQ buses, you can find out the voltage, convert that into polar form, and then you can take the real part as V and angle, magnitude as V and the angle as del. Del 3 and del 4, V3 and V4. I will explain only the second one, that is PV bus with Q2. First of all, they had converted all the things, they had taken all the things, Y12, Y23, all. Okay, now, since the first one is a slack bus, it is this. Second one is a PV bus, they had taken. Third and fourth are PQ buses, we are assuming flat start voltage. First step is finding the value of Q2. We are finding the value of Q2, we got 0.1456. What is the range they had given? 0.1 less than, Q2 less than 1. What we got? 0.14. 0.14 is lying between 0.1 and 1. So you will proceed as it is. That is finding the value of V2. After finding the value of V2, finding the real part of V2, and then holding the imaginary part as it is. Second subdivision is Q2 range is actually Q2 we got 0.1456. But in the second subdivision, they had given 0.01 less than Q2 less than 0.09. See here 0.14 is not in the range. And the point when it is not in the range, I said you should proceed it as a PQ bus. When it is in the range, you proceed as a PV bus. When it is not in the range, you proceed as a PQ bus. Now, since 0.14 is near to 0.09, we are fixing 0.09, Q2 as 0.09. And as it is not in the range, we are deleting the voltage given and taking the flat start voltage. And then we are proceeding as a PQ bus again. Then C subdivision. In the C subdivision, what we got 0.14. But the range is 0.2 less than or equal to Q less than or equal to 1. 0.14 is near to 0.2 here. So we will fix Q2 as 0.2. As it is not in the range, we are proceeding as a PQ bus. When we are proceeding as a PQ bus, given voltage is neglected and taking as a flat start voltage. So this is the concept of Gauss-Seidel problems. With this, I end the Gauss-Seidel problems. Thank you.